All right, and we're back with part 2 of the notes on graphing polynomials in factored form. In this video, we're going to do the actual graphing part. And so we're going to talk about going from a polynomial equation in factored form, learning how the degree, the zeros, the end behavior, and specifically the multiplicities affect how the graph is drawn. So in this first example, number 5, we can see the graph already, so that's nice. We're going to find the degree the same way we did in part 1. We're going to add the exponents of each factor together. There's no exponent here, so that's a 1. 1 plus 2 is 3. And then the zeros can be found by taking each of these factors, setting them equal to 0 and solving for x, or for the case of this class, just changing the signs. So the zeros are -3 and +2. And the nice thing is, if you look here at this graph, you can see at -3 and +2, those are our x-intercepts. Those are the places where the graph hits the x-axis. For the end behavior, we have a odd degree polynomial, positive leading coefficient, but we also have the graph where we can see this. So as x approaches -infinity, as we go left, we're going down. So f of x approaches -infinity. And then here, as x approaches positive infinity, as we go to the right, we're going up. So f of x approaches positive infinity. And then the question is, what is the multiplicity of the 0 at x equals 2? And we talked about this in the last video. The 2 associates with this factor. The multiplicity is a 2, or the exponent, I'm sorry, is a 2, so the multiplicity is 2. Now, one of the things that I want to talk about in our next problem, we're talking about graphing, so I'm just going to give you a little preview here. When you have a multiplicity of 1, it's going to look like this, exactly the way that it looks here. It's going to sort of go straight through that x-intercept, okay? When it has a exponent of 2, a multiplicity of 2, it looks like this. It sort of turns around. It sort of bounces back, if you will. So it doesn't go through, it just touches the x-intercept and goes back. And those are the two you sort of need to know for the purposes of this class, is that when the multiplicity is 1 for that 0, it goes straight through. When the multiplicity is 2, you have sort of this bounce. It sort of touches and then goes back. We also might see a little bit of multiplicity of 3. If it's, so this is multiplicity of 1, this is multiplicity of 2. Multiplicity of 3, it kind of looks like this, with this being the x-intercept. We might see some of those, but you won't have to graph it yourself. So let's actually do this graphing here. So in example 6, we've got negative x minus 1 times x plus 3 squared times x minus 2. First thing I'll do is I'll find the degree and the leading coefficient. So the degree here, sorry about that. So the exponent here is 1, here's 1. 1 plus 2 plus 1 is a degree of 4. And then the leading coefficient, there's no number here, but it's a negative. There's no number, it's a 1, but that negative means that it's a -1. So what this tells me is that I have an even degree and a negative leading coefficient. So what that means, and I'm going to do this little tiny graph here, and then I'll make it sort of bigger, obviously, here, but even degree negative leading coefficient means that both ends point down. And so basically, if you do this correctly with the zeros, as long as you start in the right place and you follow the correct pattern, it should just work out that way. But as we know, because we have an even degree polynomial and a negative leading coefficient, the left and right end behaviors both go towards -infinity. The zeros here we get by changing the signs of each of these factors. So the zeros are x equals 1, -3, and 2. And so what I'm going to do is I'm going to graph those. 1, -3, and 2. So that way I know where my graph is going to touch the x-axis. And the multiplicity of the 0 at x equals -3, that is the exponent here. That's 2. So the multiplicity is 2. Now, what we know is that the multiplicity at 1 and at 2 are both 1, and the multiplicity at -3 is 2. And then I use the information that I just talked about in my last example. If the multiplicity is 1, it goes straight through. And if the multiplicity is 2, it sort of bounces and just touches. I know that I'm starting down. At -3, it just touches. Go through because it's 1, go through because it's 1, and finish down. And I did this correctly, I know, because I finished down, and that's what I wanted to do if you go back to this little diagram that we just did. Because I had an even degree and a negative leading coefficient, I knew that I had to start down, and if I did everything correctly, I would finish down. Notice how it just touches here at -3 and turns around and then goes through 1 and through 2, because this has a multiplicity of 2, and then these both have a multiplicity of 1. So again, if you feel like you're understanding this, pause the video and try the next 2 problems. If you're not quite sure, follow along with me for these next 2 as well. But if you feel confident, you want to try it yourself, pause now. And we're back. So number 7 is similar to number 5. It says, look at the graph of the polynomial function f of x equals x plus 1 cubed times x minus 2 squared. First thing we'll do is we'll find the degree. The degree of the polynomial is found by adding up the exponents, in this case 3 and 2. 3 plus 2 is 5. The zeros here are found by changing the signs of the factors or looking at the x-intercepts. Since we do have the graph, they're here at -1 and 2. We do have an odd degree polynomial and a positive leading coefficient, so even without the graph, we would be able to find our end behavior. But also, as we can see here in the actual graph, as we go left, we're going down, and as we go right, we're going up. So, down, up. So as x approaches -infinity, as we go left, we're going down. F of x approaches -infinity. And as x approaches positive infinity, as we go right, we're going up to positive infinity. And then it asks us, what is the multiplicity of the 0 at x equals 2? The factor associated with that is this x minus 2. The exponent here is 2, so the multiplicity is 2. And for our last problem here, we've got f of x equals x minus 4 squared times x plus 7 times x plus 2. We'll find the degree. 2 plus 1 plus 1 is 4. The leading coefficient, there's no number in front here, so the leading coefficient is 1. So we have an even degree and a positive leading coefficient. So again, my little sketch here, ends both go up. So as x approaches -infinity, we're going up. F of x approaches positive infinity. Same thing here, as x approaches positive infinity, we're going up. The zeros can be found by changing the signs of each factor. So x equals 4, -7, and -2. So I'm going to graph those. My x-intercepts for -7, -2. And the multiplicity at x equals 4, that's here. The exponent is 2, so 2. And then we're going to take this information, the fact that it starts up and finishes up. We're taking the fact that positive 4 has a multiplicity of 2, so that's going to be a bounce or a turnaround. The other two have multiplicity of 1, so it's going to go straight through, and we'll see what we end up with. So we're starting facing up. We go straight through at -7, straight through at 2, and bounce, just turn around at 4. Okay? And so my graph isn't perfect, but that's the idea of what this is going to look like. These are really just sketches. The y values don't matter, which is why there's no y-axis here. This is just sort of a sketch. But notice here it goes straight through because it has a multiplicity of 1, straight through because it has a multiplicity of 1, and then it turns around and just touches but bounces back because at 4 it has a multiplicity of 2 instead of 1. Sorry, multiplicity of 1 here, multiplicity of 1 here. I think that's what I said, but in case I'm wrong. Multiplicity of 1 here, and 2 here. Okay? So hopefully you found this helpful. Please be sure that you've copied this down in some way for your own notes before you try the things that we assign you. And then later in the week, you will get a set of practice problems. Again, you'll get them, you'll try them yourself first, and then I'll have a video going over those as well. Have a great one, guys.